Introduction to Quantitative Research, Data Collection. By the end of this session, you should be able to identify the steps in the process of quantitative data collection, define different approaches used to sample participants for a quantitative study, describe the process of obtaining permissions to study individuals in research sites, list different options for types of data often collected in quantitative research, identify how to locate, select, and assess an instrument for use in data collection, describe procedures for administering quantitative data collection. Identifying the unit of analysis, in other words, who will be studied. The unit of analysis is the level, for example, individual, family, school district, from which the data will be gathered. There may be different units of analysis. It could be one for the dependent variable or another one for the independent variable. But it is important that for quantitative research, you should be very clear about what your unit of analysis is. You also need to be able to distinguish between population and sample. A population is a group of individuals that have the same characteristics. A sample is a subgroup of the target population that the researcher plans to study for the purpose of making generalizations about the target population. Obviously, for a researcher, to study a sample is way more efficient because you're looking at smaller numbers and you're looking at less expenses. To study an entire population, depending on the size of the population, it's going to be really difficult and highly expensive. Taking note of these, we need to remember that samples are only estimates, and the difference between sample estimates and the true population is what we refer to as the sampling error. So the results of our quantitative analysis always produce a sampling error, and we need to be able to report this sampling error. If we increase the size of our sample in relation to the population, you will find that the sampling error reduces as well. Let's take a look at this graphic. The target population is the big circle here, shaded in blue, and the sample is only a part of the target population. For example, all teachers in high schools in one city could be the population, and a sample of that could be all high school biology teachers. Of course, they belong in that one city. College students in all community colleges could be the population, and your sample would be students in one community college. It's a smaller subset of the entire population, obviously. Another population example could be adult educators in all schools of education, whereas you could say that your sample would be adult educators in 5 schools of the education in the Midwest. Okay, this example is obviously taken from a North American perspective by referring to the place as Midwest. When you take a look at sampling, there are 2 types, probability and non-probability sampling. Probability sampling is a selection of individuals from the population so that they are representative of the population. In other words, each member of the population, if you're using probability sampling, has an equal chance of being selected for your sample. Non-probability sampling is selection of participants because they're available, convenient, or represent some characteristic the investigator wants to study. So if you have a non-probability sample, it's safe to say that the members of that sample did not have an equal chance of or were selected, and the others who were not selected did not have an equal chance of being selected for this particular sample. Right? So that is the difference between probability sampling. Each member of the population has an equal chance of being selected, whereas for non-probability sampling, not everyone has an equal chance of being selected. Let's take a look at this graphic as it explains to us types of quantitative sampling. So you have probability sampling, what I explained just now, and you have simple random sampling. Simple random sampling, for example, if you wanted to get a simple random sample of UNE students, what I would do is I would put all the names of UNE students on a piece of paper, put it in a big box, and then ask someone to draw 100 names from the lot. So this is simple random sampling. Each name has an equal chance of being selected. Systematic sampling is what we do here is we have an alphabetical listing of all the students of UNE, and then we say that, okay, we're going to be choosing only the 10th student in that list of names. So number 10, number 20, number 30, number 40. That's an example of systematic sampling. Stratified sampling is when you say, okay, I want to get a stratified sample from all the UNE students. So I would get all the names of UNE students and divide them first into males and females. And then I tell myself I would like to get 100 members of the sample. So 50 would be stratified into males, 50 will be stratified into females, and then I do either systematic sampling for the male and female group, or I do simple random sampling for the female and male groups. Multi-stage cluster sampling, well, what happens is you actually you first cluster your samples. It could be by gender, it could be by ethnicity, it could be by age group, and then once you have identified a cluster, you set several stages. The first stage could be we are going to select those who have had exposure to UNE in a shorter time period, in other words, the new students, and then you could get the next stage would be students who have been at UNE for a medium time period, say 3 to 4 years, and then those who have been at UNE for a longer time. So you cluster it once, and then you essentially set several stages. And your purpose is to be able to get a sample that is truly representative of the entire population. So these are various examples of probability sampling, this particular part of the graphic here. And then you have non-probability sampling. And one example of this is convenience sampling. You essentially choose a sample of all the UNE students who happen to be taking the same unit as you do, right? So that's a convenient sampling. It's more convenient to reach out to them. Snowball sampling is when you have no access to a lot of, let's say, UNE students, so you talk to one and then you ask that other student to refer to you others who may be interested in doing the research. So they'll give you names and then you contact those other persons. They also give you more names, so it snowballs until you are able to reach a good enough size for your sample. Two different ways of sampling. Simple random, as I explained earlier, selects a sample from the population, so all in the population have an equal chance of being selected. Systematic, choosing every nth individual or site in the population until the desired sample size is achieved. Multi-stage cluster sampling, a sample chosen in 1 or 2 stages because the population is not easily identified or is large. Stratified sampling, you stratify the population on a characteristic, gender, and then sampling from each stratum, as I explained earlier in the graphic. Let's take a look at this. Right? Sorry, let's get back to that. So the population is 9,000. Let's say that there are, this is an example of proportional stratification sampling. So the population is 9,000 students in a particular school, and there are 6,000 boys and 3,000 girls. So you want to get the proportional stratification sample from all the students. So boys consists of 66% of the population, girls consist of 33%. So what you need to get for your sample is 200 boys and 100 girls. So your sample should be 300. But this is just a number. How you're able to arrive at that number could be through simple random sampling, could be through stratified random sampling, could be through multi-stage cluster sampling, right? So you can approach it in various ways. I've already talked about this earlier. Convenience sampling, participants are selected because they're willing and available to be studied. Snowball sampling, the researcher asks participants to identify other participants to become members of that sample. Permissions are needed in conducting research. You need to obtain permissions from the institution or the organization, for example, the school district. Site specific, if you're doing research in a school, you need to get approval from that particular school. You need to, of course, get the consent from individual participants. If you're looking at minors, you need to get parents of participants who are not considered adults to give their permission. And if you are part of a university, which all of you are, those who are listening to this particular session, well, you need to get campus approval, university or college, or institutional review boards for your field work, for your research. How do we link data collection to variables and questions? The flow of activities, let's take a look at the sample. So you identify the variables. An example could be the notion of self-efficacy as one learns from others. You take a look at how other people, let's say, teach mathematics, and you're a beginning teacher, you take a look at how they teach, and in so doing, your notions of self-efficacy can either improve or could deteriorate. So that's the variable that we're trying to explore. So you operationally define the variable. You define self-efficacy. We define it as a level of confidence that an individual can learn something by being taught, by observing, by looking at what others do. So that's operationally defining the variable. Then the next one, of course, is locating data. Measures, observations, documents, with the use of questions and scales. These are measurement scales, psychometric tests that are available, particularly in the field of educational psychology and psychology in general. So there is this self-efficacy attitudinal scale from Bergen. There are 13 items that could be used as the data measuring instrument. And then you collect data using the instruments, and it yields numeric scores. So you give it to your sample of students, pre-service teacher educators, and you want to find out how their self-efficacy changes after they have been exposed to another individual, once they have learned from others. And so the scores of each item range from 0 to 10, with 10 being completely confident. So this is how you link data collection with your variables and with your questions. Types of data measures. An instrument is a tool for measuring, observing, or documenting quantitative data. There are several types of instruments. One is performance measures, test performance. You have attitudinal measures, measures feelings towards educational topics, for example. You have behavioral measures when individuals actually use tools to be able to look at changes, modifications in the behavior of other individuals. And you have factual measures, documents, records that indicate change or no change from one period to the other. These are different types of instruments that you can use in data collection. Now, how do you locate or maybe even develop an instrument for data collection? You can look in published journal articles. Because the journal articles, as I mentioned in the previous session, that's really where you are exposed to real quantitative research, not the textbook approach, but really looking at journals, reading what people have undertaken for their research, looking at their experiments, and seeing the issues and challenges that they experienced. You can also run an ERIC search, ERIC, and a descriptor for the instrument you want in an online search to see if there are articles, journal articles, or conference proceedings that are refereed that contain the instruments that you're looking for. You can also check tests in print. You type this in your search engine, you were able to take a look at an available listing of data collection instruments. You can also take a look at Mental Measurements Yearbook. It's published by the Bureau Center at the University of Nebraska, and they have a collection of all of these. Or you can develop your own instrument. But when you develop your own instrument, this has to be based on a theoretical foundation, right? Criteria for choosing a good instrument. Have authors developed this instrument recently? Is the instrument widely cited by other authors? Are reviews available for the instrument? Does the procedure for recording data fit the research questions, hypothesis in your study? Does the instrument contain accepted scales of measurement? Is there information about the reliability and validity of scores from past uses of the instrument? This is important when you choose a good instrument. I have a PhD student who just completed his PhD. I'm his supervisor, although I'm here at the University of New England. He completed his PhD with the Institute of Education at the University of London, together with the National Institute of Education in Singapore. Now, the instrument that he used was is referred to as the Epistemological Beliefs Questionnaire, the EBQ. And what he did essentially was he tested current versions of the EBQ, and he was able to create his own version of the EBQ. That was his contribution. So you actually can develop your own instrument, but what he did was he developed it, he tested it, he collected data, and after several rigorous peer reviews from supervisors and also from an external examination committee, his ideas have been formalized and it's part of existing literature. So it's possible to create an instrument, but these questions that you see in your graphic are essentially questions that you have to ask yourself in choosing a good instrument. Reliability are scores from measuring variables that are stable and consistent. Reliability essentially tells you that when you use that measurement tool, it tells you the information that you're looking for. The bathroom scale is an example of this. So when you step on it today, it should measure a particular weight that you have. If you step on it later during the day, it should also indicate the same measurement. It's reliable in that sense. Now, what are different types of reliability? Test retest. Scores are stable over time. What I just explained earlier about using the bathroom scale. Alternate forms, equivalence of two instruments. That's another way of testing reliability. Alternate forms, and then combining with test retest. Inter-rater reliability, similarity in observation of a behavior by two or more individuals. Example, three individuals or five individuals take a look at a particular action and then they create scores. This is what you see in the Olympics or in the Commonwealth Games. A gymnast performs a routine and the judges who are chosen, they're usually experts in the field and they give scores. And usually they would be giving scores that are very close to each other, and that essentially tells you that there is a high degree of inter-rater reliability. Another way of looking at it is through what we call internal consistency. Consistent scores across the instrument. In subsequent sessions, I'm going to explain this to you. Internal consistency in terms of the reliability of instruments. Validity. Scores from measuring variables that are meaningful. Right? So there are various types of validity. One is content validity. So the instrument that you're looking at represents all the possible questions that could be asked in relation to that particular issue that you're looking at. It's also criterion reference validity. Scores are a predictor of an outcome or criterion they're expected to predict. If your test wants to measure, let's say, happiness, and when you employ the test, you should be able to measure degrees of happiness. If you're able to measure something else, like levels of anxiety or levels of dissatisfaction, then there's must be something wrong with your instrument because it doesn't seem to be valid. It's not registering criterion referenced validity because the score should predict an outcome or criterion that you have identified as part of your expectation. There's also construct validity, which helps determine the significance, meaning, purpose, and use of the scores from using a particular measurement tool, a measurement instrument. What are the scales of measurement? Again, in an earlier session, we talked about categorical and continuous variables. Here, we're going to be going deeper. So categorical measures can be divided into two. Nominal is one and ordinal is the other one. Categories that describe traits or characteristics that participants can check. Male or female. Student or not a student. Student or lecturer or school staff. These are different examples of nominal categories. They're named. That's what nominal means in Greek, nomine. Then you have ordinal. Also categorical, participants rank order a characteristic, trait, or attribute. So you have people who would say that I am happy, I am more happy, I am really greatly happy, for example, right? So that's an ordinal scale. The participants are able to rank an experience according to a particular attribute. Let's say happy, happier, or happiest. The problem with the ordinal, not really a problem, but we need to remember that in an ordinal scale, the distance between happy, happier, and happiest, it's not something that is really precise. The other scales will be continuous variables, and the first one will be interval continuous measurement. So it provides continuous response possibilities to questions with assumed equal distances. We can safely assume that the distances between the choices given by the respondents are equal, right? So you see some degree of overlap in ordinal interval, but the good researcher, is able to clearly define what the interval variable is in order to avoid confusion. For example, if you take a look at scores in a test, so the lowest that you can get is a 0 and the highest is 100. You could actually create this into an interval type of variable by saying that one interval will be those who have scored from 0 to 20, and another interval will be those who scored 21 to 30, and another interval will be those who scored from 31 to 40. So you have looked at a continuum, and then you have divided them into these intervals, right? You could safely assume that the distances between each interval is assumed to be equal. Ratio, continuous variable, this is where you have a scale with a true zero, and there are unquestionably equal distances among units. Using the score as an example again, instead of using it and dividing the score continuum into intervals, you can actually just use the score itself. So someone who scores a 10, that's one variable. Another person scores 50, another person scores 70, 100. So the differences in each of these scores you could actually compute, and you can say that each unit, 1, 2, 2, and 3, have equal distances. So these are the different scales of measurement. That is important when we start doing data collection. Procedures for administering the data collection. We develop standard written procedures for administering an instrument. We train researchers to collect observational data. We obtain permission to collect and use public documents. And then we respect individuals and sites during data gathering. This is what is important in the ethics requirements that need to be completed. I've suggested that you take a look at the article by Pierce and Helen Chick in 2011, Teachers' Intentions to Use National Literacy and Numeracy Assessment Data, a Pilot Study. This is from the Australian Education Researcher. And when you take a look at this article, I invite you again to reverse engineer it, to dissect it. Identify key research problems, recognize literature used, spot the purpose of the research, ascertain how data was collected, determine how analysis and interpretation was made, and describe how reporting and evaluation was done. As mentioned earlier, I think this is the best way for you to really get grips into appreciating and understanding the fundamentals of quantitative research by looking at original sources, articles. I also invite you to reflect. In relation to this article that I hope you've had a chance to read, that attempts to relate teachers' intentions with student achievement, for example, literacy and numeracy assessment data, I want you to give your comments. How effective or ineffective is quantitative research in determining possible relationships between teachers' intentions and student achievement? Justify your answers. Are the variables used to operationalize teacher intentions and student achievement appropriate? Justify your answers. And that ends our session on Introduction to Quantitative Research, Data Collection. For further questions and clarifications, don't hesitate to get in touch with me in the email that you see on the slide. Thank you.